Hello class, this is section 5.5, math 1430. So let's take a look at what we have. 5.5, derivatives of logarithmic functions. We're only going to do logs with base e in this section and in this course. So by base e, I mean log base e of x, which is almost always written as just ln of x. So you're going to see this notation a lot. And now here are the two rules for derivatives of these natural logs where the base is e. Here's the first rule. If it's just the simple, you want to take the derivative d dx of ln of x, the answer is going to be 1 over the argument. This argument is x. So the derivative of the natural log of x is just 1 over x. And then the other rule, if you have a more complicated log, let's say you want to take the derivative, meaning d dx, of the natural log of u, where u is some function of x. Maybe u is 5x squared, for example, something other than the simple x. So if you want to take the derivative of the natural log of u, then it's going to be 1 over u times the derivative of u with respect to x. So times du dx. So we're going to use these rules here. Actually, for this video, I'm only going to use number 2 because number 1 is pretty darn easy. The derivative of the natural log of x is just 1 over x. So let's take a look at question number 1. If I want to take the derivative, we want to find the derivatives. If I want to find the derivative of the natural log of this argument, notice this is not just the simple x. So we're going to use rule number 2. Think of this as like your u. What's the derivative of the natural log of u? It's going to be 1 over u times the derivative of u with respect to x. So here we go. The derivative y prime, or I could write dy dx, is equal to 1 over the argument times the derivative of the argument. What is the derivative of this argument? Well, the derivative of the first term is 6x minus 0, which is just 6x. And then we get our final answer. When I multiply the numerators, I get 6x over 3x squared minus 5. Done. So there's the first problem done. So we use this rule here, where u was, in this case, u was 3x squared minus 5. So what's the derivative of the natural log of some expression? It's 1 over the argument times the derivative of the argument. du dx means derivative of that u with respect to x. Notice the answer does not include logs, so that's a common mistake to write ln in your answer. But it's just 1 over the argument times the derivative of the argument. That is how you find the derivative. Okay, let's go to the next problem. These look similar. Ln of x to the fifth versus the ln of x to the fifth. So let's see how we handle these. Let me do this one first. F prime of x equals, notice the argument of this log is simply x. That's the argument. And the whole thing is raised to the fifth power. So we're going to have to use the power rule in conjunction with the chain rule. So f prime of x, you bring down the 5, keep that base ln of x. Now it's raised to the fourth. And then by the chain rule, we got to go times the derivative of the inside. What is the derivative of the ln of x? By rule number 1, it's just 1 over x. And then you want to simplify. If it helps you, you can think of this over 1. So now when you multiply fractions, you do not need a common denominator. Just multiply the numerators. So the numerator product is just 5 times the ln of x to the fourth over, and then when I multiply the denominators, 1 times x is just x. And that is done. So that would be the derivative for this first function. And now to find this derivative, let's see, I'm running out of space here. I'm just gonna erase this now because I think you've seen it. Okay, you can always go back and pause your video just to see this again. So let me get rid of this and this problem. Okay, so now, given f of x is equals to the natural log of x to the fifth, if it helps you, you don't have to do this. You can always say the argument is x to the fifth. That's more clear. So to find the derivative f prime of x, this is like the natural log of u, where u is some function of x. The derivative of the natural log of an argument is going to be 1 over the argument times the derivative of the argument. by the power rule, 5x to the fourth. So this is going to equal, think of this over 1 if it helps you, multiply the numerators for 5x to the fourth, multiply the denominators for x to the fifth, and then we can simplify again. So I only have 4 x's on top, I got 5 x's on the bottom, so the x's all cancel except for 1 x on the bottom. So my final answer is just 5 over x. I'll box it this time. So 5 over x is my final answer for that derivative. Okay.
Just for fun, rewrite f of x using the property of logarithms. Isn't it when you have an argument raised to an exponent, you can bring that exponent out front as a coefficient?
So here's what my brother is saying.
Well, we should get the same exact answer.
So by property of arguments, this exponent can come down.
Property of logarithms, right?
So I get 5 times the ln of x. That's what f of x is equal to. So by property of logs, f of x is equal to 5 times the ln of x. And now we're ready for the derivative. F prime of x equals, pull out that constant factor of 5 times, and now what's the derivative of the ln of x? 1 over x. What's 5 times 1 over x? Same answer, 5 over x. So different ways of getting the same answer. So we're done with that problem. And now let's go to this problem here, number 3. I've got 2 ways to do this problem. To find the derivative, I could just say y prime equals 1 over this argument times the derivative of this argument, which would involve the product rule, because this argument is a product. It's factor times factor. So that way takes a little bit of time. So instead of doing it that way, which you can, I'm going to use properties of logs to make my derivative easier. So still y, because I'm not ready for a derivative. Remember that the log of a product is the sum of the logs. So it's going to be the ln of x plus the ln. And isn't square root the same thing as 1/2 power? We want to avoid radicals with derivatives. So let's make the base 2 minus x squared. So that's the first step that I'm going to do. Use a property of logs. This is the same thing as this. It's still y. No derivative yet. Okay, and then let's use this property that we just talked about. The exponent can come down. So that will make the derivative easier still. So the whole point of using these properties of logs is to ultimately have the derivative to be a lot easier than the original derivative. So this is going to be, bring down the 1/2 by a property of logs as a factor. So it's 1/2 ln of 2 minus x squared. Now I'm ready to take the derivative because this doesn't look too bad and this doesn't look too bad. So y prime equals, and the derivative of a sum is the sum of the derivatives. So what's the derivative of the first term? Just 1 over x. Plus, and now whenever you have a constant factor in front of a function of x, the derivative is going to be pulling out that constant factor, multiply it by the derivative of this expression here. So what's the derivative of the natural log of some u? It's going to be 1 over that u, 2 minus x squared, and then by the chain rule times the derivative of this expression, the derivative of the argument. Again, if you think of this as u, the derivative is going to be, the derivative of ln of u is 1 over u times the derivative of u. So the derivative of a constant is 0. What's the derivative of negative x squared? That's going to be a negative 2x by the power rule. Okay, let me clear some space. So I'm going to continue over here now. So y prime is equal to, we got the 1 over x. And now let's look over here. These are all factors. Factor times factor times factor. So the 2, but not the negative, cancels with this 2. The 2 on top cancels with the 2 on bottom. So this is now like a negative 1, a negative 1. So we already took care of this term. So this term here, we're just trying to simplify this term here. The numerator 1 times a negative 1 is a negative 1.
X2, negative x goes in the numerator.
Oh yeah, so it's going to be...
minus x?
Yeah, it's going to be minus, you could write plus a negative x, but that's just going to be a minus x over, and then I have the 2 minus x squared. You cannot cancel these x's at all because this x squared is a term. You can never cancel terms. So I would just leave that as the final answer. I could get a common denominator of x times 2 minus x squared and write it as a single fraction, but I think this is plenty good enough. So that would be my final answer for y prime. But if WebAssign wants completely simplified, you would just have to get a common denominator. So I'll just for fun write what the LCD would be. It's the product of the denominators. So this fraction here, you'd have to multiply by x over x. This fraction here, you'd have to multiply by 2 minus x squared over 2 minus x squared. So does this look good, everyone? No mistakes, I don't think. Let me just double check here. Negative 2x. So I got 1 over x and then minus.
Looks good, looks good.
Okay, so here's the final problem here. So whenever you see radicals, get rid of them by using exponents. So I'm going to rewrite f. I'm not ready for a derivative yet. Square root means 1/2 power. So ln of 2x to the 1/2. So now it looks like I'm ready for a derivative. What's the argument of this log? It's 2x. Okay, so let's take the derivative. F prime of x is equal to, so we're going to have to, because this is a composition of two functions, we're going to have to use the chain rule. So the first part is to bring the power down, keep that ln of 2x, decrease the power by 1, 1/2 minus 1 is a negative 1/2, and then by the chain rule we got to go times, and now what's the derivative of the inside part? Well, the derivative of the natural log of an argument is 1 over the argument times the derivative of the argument. The derivative of 2x is the 2. Okay, so let's simplify this. I'm going to cancel this 2 on the bottom with this 2 which is on the top, because you can think of this as over 1. Or I could have canceled those 2's instead. It doesn't matter. Okay, so for my final answer, this negative exponent, that means I'm going to put the ln of 2x on the bottom as a positive 1/2.
Right as a square root,
yeah. Because my original problem involves square roots, I'm going to put it back to square root form. So in the numerator, it looks like I have the 1. This is going to go downstairs because of the negative exponent, and I got another 1. So my numerator is just 1. My denominator, I got a 2x in the denominator. And then this, I'm going to write as the square root, because that means the same thing as 1/2 power, ln of 2x. And that's my final answer. I'll put a little block. Done. And just make sure that looks okay. Yeah, I think that's all good. So good night, everyone.